Ever wondered how neural networks, those complex systems that mimic the human brain, learn and evolve? It's a fascinating process that hinges on a key concept known as backpropagation. Imagine a neural network as a labyrinth. You start at the entrance and your goal is to reach the center. Each decision you make, each turn you take, brings you closer to or further from your goal. Now imagine that every time you make a wrong turn, the labyrinth rearranges itself to make the correct path a little more clear. That's essentially what happens in a neural network during backpropagation. To understand this better, consider an example. Suppose we have a simple neural network designed to predict whether it will rain based on the temperature and humidity. We provide it with inputs, say 25 degrees Celsius and 80% humidity, and it makes a prediction. But how does it learn from its mistakes? Here's where backpropagation comes in. When the network makes a prediction, it compares its output with the actual result. If it predicted rain and it didn't rain, it knows it made an error. Now, instead of simply moving on, it goes back through its layers of neurons, adjusting the weights assigned to temperature and humidity based on how much they contributed to the error. This process, akin to retracing steps in a labyrinth, is called backpropagation. But what does this adjustment look like? Well, the network calculates the derivative of the error with respect to each weight, essentially measuring how much a small change in the weight would affect the error. It then adjusts the weights in the opposite direction of the gradient to minimize the error. This is done using a technique called gradient descent. By repeating this process over many cycles of input data, the network gradually improves its predictions. Each mistake becomes a learning opportunity, transforming the network into a more accurate predictor over time. So, to summarize, backpropagation is a method used in neural networks to adjust the weights of inputs based on the error in prediction. It involves calculating the derivative of the error with respect to each weight and adjusting the weights in the opposite direction of the gradient. This process, repeated over many cycles of data, allows the network to learn from its mistakes and improve its predictions. It's a fascinating glimpse into how these complex systems learn and evolve, much like navigating through a labyrinth. But instead of reaching the center, the goal is continuous improvement, a relentless pursuit of accuracy. And that's the beauty of backpropagation. It's not just about making predictions, but about learning and evolving with every mistake. It's what makes neural networks not just powerful, but truly intelligent.